A series of lines in the spectrum of atomic hydrogen lies at wavelengths 656.46 nanometer, 482.7 nanometer, 434.17 nanometer, and finally 410.29 nanometer. What is the wavelength of next line in the series? Now what you need to do is, the first step is to find out that to which region the wavelengths belong. Right? To which region they belong? See the wavelengths. Isn't it the visible region? The visible region is from 3800 angstrom to 7000 angstrom. So they are lying in the visible region, right? So they belong to visible region. Now students, which series is in the visible region? It's Lyman, Balmer, Bastian, Farn, Brackett. Which of them is in the visible region? The Balmer series, right? So here we will write it as Balmer series. These wavelengths belong to what? These belong to Balmer series. Now we need to find out the next wavelength. For finding out the next wavelength, what you require? That from where the transition is being taking place. For that you require the n value. Now here, when the wavelength is in Balmer series, what is n1 equal to? It is 2. That is, every time the excited electron is coming back to n1 level. Getting my point? Now we have got n1, but we don't know n2 for the next wavelength, right? And we don't know n2 for this wavelength also. So let's find out n2 for lambda is equal to 410.29. And we know for the n1 for this. Now what formula we will apply, students? The wave number, that is 1 by lambda, is equal to r into 1 by n1 square minus 1 by n2 square. Right? Now what is 1 by lambda? Lambda is given here, that is the wavelength 410.29 multiplied by 10 to the power minus 9, and that is equal to the value of r. R is what? 109.673, or you can simply remember 1.096 into 10 to the power 7 multiplied by 1 upon 2 square minus 1 upon n2 square. Right? So we will calculate this. So what do we want here is, we want 1 by n2 square. So this will be 1 divided by 410.29 multiplied by 10 to the power minus 9 multiplied by 1.910. It should be 109.673, and that is equal to 1 by 4 minus 1 by n2 square. I hope you can solve this equation, and from here we are getting n2 is equal to 6. That is, when the electron is moving from 6th energy level or 6th orbit to 2nd orbit, the wavelength of the light emitted is 410.29. Now students, what will be the next wavelength in the series? The electron will be moving from what? For the next wavelength, electron should move from N2 is equal to 7 to N1 is equal to 2. Right? Now your 1 by lambda will be equal to 109673 multiplied by 1 by 4 minus 1 by 7 square. Right? You just solve this equation and you will get your wavelength is equal to 397.2 into 10 to the power minus 7 centimeters, or lambda is equal to 397.2 nanometers. Right? So what will be your answer? What is the next wavelength in the series? The next wavelength in the series is 397.2 nanometer. Is my point clear? How did we find out? How did we find out? Just by finding out the energy level, or the energy level from where the transition has taken place, and given out the wave of 410.29. Right? So we have got our answer that the next wavelength should be 397.2 nanometer. So the next wavelength is 397.2 nanometer in the series, and which transition it corresponds to? N2 is equal to 7 and N1 is equal to 2. Right? So it corresponds to N2 is equal to 7 and N1 is equal to 2.